Hello everyone, in today's episode of Things No One Asked For, we will be finding different measurements of an Among Us character spinning. The angular velocity, acceleration, regular velocity, and how far it will go are just a few examples. This video was made for those people who say, what will physics A-level even teach you to help you in life? This is what it will teach you. So you're thinking, what makes this monkey caveman brain person qualified to teach us? Well, for your information, I did my Unit 4 physics paper and I have an A in physics according to this certificate, which is official. Still, I hate myself and decided to do wrong things with my knowledge. I could probably work out teleportation. I'm so sorry. I don't know what I'm thinking. Okay, back to the video. Anyways, before we can start the calculations, we need a bit of backstory. Among Us is a funny game which involves two groups, the imposters and the crewmates. The role of the imposter is to get rid of the crewmates and to be the last people standing, and the role of the crewmates is to get out the imposters. Let us now proceed with the calculations of different values when a crewmate or imposter gets ejected. First of all, we need to get the things we know. A quick Google search shows us that the weight of an Among Us character is 92 pounds, or 41.7305 kilograms, and it is 106.68 centimeters, which is just about 700 million times as wide as a glucose molecule, and it's about half as heavy as a kangaroo. Assumptions. Space has no air resistance, gravity will not slow him or her down, character is modeled as a perfect circle with a mass acting in the center of it. Now, let's write our variables. Height, 106.68 centimeters. If we model it like a perfect circle, we can assume that the radius is 53.34 centimeters, which is 0.5334 meters. The weight is 41.7305 kilograms. Assuming it's on Earth, the mass will be 5.37 kilograms. Next, we need the time for one rotation. Looking at this video of the character rotating,
I forgot to record this bit. I basically watched the video multiple times and took multiple reading in order to get a more accurate results. 14 minutes of my life I am never getting back.
As we can see from this video, which I put on 0.25 speed to reduce error, the time for this Among Us to complete for this Among Us character to complete one full rotation is 6.83 seconds in 0.25 speed, so 1.71 seconds to complete one rotation. Now, we have to work out the angular velocity. The equation for angular velocity, which I will be using, is time period, which is the time for one rotation, equals 2 pi divided by the angular velocity. Rearranging this equation for angular velocity, we get a value of 3.67 radians per second. To work out the velocity, we use velocity equals r, the radius, times the angular velocity, which gives us an value of 1.96 meters per second. Next is the acceleration. For this, we use acceleration equals the radius times the angular velocity squared, which gives us an acceleration of 7.2 meters per second squared. The centripetal force acting on the Among Us character can be worked out using force equals mass times radius times angular velocity squared, so the force would be 39.15 newtons. Our final calculations will be how fast it's moving horizontally, and if it gets ejected from Earth, how long will it take for it to reach the Sun. From these videos, we can see that the character is moving at a constant velocity. Therefore, we can use v equals dt. However, we don't have d or t. But we can use the time taken. We can find out the time taken for it to move 1 kilometer or 1,000 meters. Using d over v equals t, we can see that it takes roughly 510 seconds to travel a kilometer. Distance from the Earth to the Sun is 151.7 million kilometers, give or take, which means that this silly little character will travel for about 7.7367 times 10 to the 10 seconds to reach the Sun, which is roughly 2,453 years. Remember, it's traveling at just under 2 meters per second, and also remember, it will never actually reach the Sun. It will probably burn and melt in upper atmospheres. Here are some references so that the numbers make sense. Velocity, it's about 1.5 times as fast as walking pedestrians in Manhattans. Now that's just wild, like, imagine being, I don't even know where I'm going with this. Imagine just being in Manhattan, walking around, and then you see a character that's half a meter tall rotating by you. It's crazy. The force. It's about the same as an average housefly hitting you with an acceleration of 3.2 million meters per second squared. Which, if you can't really imagine, I don't know, it's a housefly. Just do the math in your head. Acceleration. Acceleration. Okay, so there are two variables for this acceleration. Using a Unit 5 equation, g equals the gravitational constant times m over r squared, we can get two different measurements. We do one for the mass and we do one for the radius. When we use the median of the mass of the planets in our solar system, we get a mass of, drumroll please, 9.49 times 10 to the 26 kilograms, which is as heavy as 6.5 times 10 to the 26 slugs. That's a lot of slugs. I think that's more slugs than there are on planet Earth. Probably. Which gives us a radius of 1.32 times 10 to the 8 meters, which is actually 20 times, give or take, bigger than the Earth, which is pretty cool. When we use the median of the radius of all the planets in the solar system, we get a radius of 3.61 times 10 to the 7 meters per second, which is about 80 times as long as the Grand Canyon. Using this radius, we get a mass of 3.90 times 10 to the 18 kilograms, which is about 0.00000000002 times as heavy as the sun. Isn't that just fantastic? I know those numbers mean absolutely nothing to you guys, but to me, they also mean nothing. I don't even know what I use that as a comparison. It's still kind of heavy. It's like more than I can lift, most likely. Okay, so this is where the video ends. However, this is where the video of the calculations ends. However, as a true physicist, which I'm not, I'm just pretending to be one, we must see the things that I did wrong. The first one is that I assumed that I am qualified for this. The second one is I made this video. Third thing is I once stole. The fourth thing is that the mass of the Among Us character acts in the center of the body. The character is modeled as a perfect circle, which it isn't, and the character will forever travel in a straight line, which it won't. This just means that I have a higher percentage error in all of my calculations and hypothetical observations, but it's still pretty cool that using physics, we can work out these values, which is, I mean, they're probably like kind of off, but it's still pretty cool. Thanks for watching, and tune in next time where I'll work out something stupid that, hey, no one asked for. Thanks for watching.